उम्मीद है कि आप लोग खैरियत से होंगे। आज हम केमिस्ट्री का एक प्रैक्टिकल डिस्कस करने वाले हैं जिसका टॉपिक है या नाम है ओस्टवाल्ड विस्कोमीटर। स्टेटमेंट है हमारे प्रैक्टिकल की, डिटरमिन द विस्कोसिटी ऑफ लिक्विड एट रूम टेम्परेचर बाय विस्कोमीटर। चलिए हम स्टार्ट करते हैं। सबसे पहले हम लिखेंगे इसके अंदर मटेरियल्स रिक्वायर्ड: विस्कोमीटर, सक्शन पंप, स्टैंडर्ड लिक्विड, डिस्टिल्ड वाटर, turpentine oil, test liquid, dropper, burette, energy specific gravity bottles and stopwatch। अब हम आते हैं अपने नेक्स्ट पॉइंट की तरफ, ओस्टवाल्ड विस्कोमीटर वर्किंग एंड प्रोसीजर, कि ये किस तरह वर्क करता है और इसका प्रोसीजर क्या है। ओस्टवाल्ड विस्कोमीटर हैज़ टू बल्ब्स। इट कंसिस्ट ऑफ वाटर limb to transfer liquid. It is a U-shaped tube. There are two markings near second bulb. Upper is marked as mark A and lower is marked as mark B. On the upper side of the bulb, a rubber sucker is fitted to suck fluid. To determine the viscosity, we transfer fluid from wider limb by the help of pipette. It flows through the bulb 1 as it fills. From the other side, it sucks and it passes through U-shaped tube या U-tube and capillary tube to fill bulb 2. Bulb 2 is marked from the upper and lower ends as upper as A mark and the lower is marked as mark B. We allow liquid to flow from upper mark A to lower mark B. Time is recorded and we determine the viscosity of the liquid according to this time, means our noted time. Procedure: to find the viscosity of any liquid, we compare it with standard liquid like distilled water whose viscosity is known to us. Point 2. To perform it, we will take a clean and dry Ostwald's viscometer and clamp it on a burette stand vertically. Number 3. We transfer distilled water in Ostwald's viscometer with the help of pipette to fill the bulb 1 with distilled water. Point 4. After filling bulb 1, we will attach sucker on the other side of the limb to suck water from the bulb 1 so that the bulb 2 will be filled 1 to 2 cm above the upper mark. Point 5. The distilled water in bulb 2 will be allowed to free flow. As the water minutius reaches upper mark A, we will start the stopwatch, and when the minutius reaches the lower mark B, we will have to stop the stopwatch. Point 6. We note that the time which water takes to flow from upper mark A to lower mark B and stop the stopwatch. Point 7. We twice repeat this to get accurate reading. We do repeat the same process with the test liquid, yani turpentine oil, whose we have to determine the viscosity. Point 8. We again use Ostwald viscometer after drying. First of all, we have to transfer turpentine oil, so we transfer it to bulb 1 with the help of pipette. Point 9. Volume of turpentine oil will be the same as of the distilled water with turpentine oil. We completely filled bulb 1. We used sucker to move turpentine oil 1 to 2 cm above from the upper mark of the bulb 2. Point 11. Now we allow turpentine oil to free fall. As minutius of the turpentine oil enters in the upper mark A, we will start the stopwatch to note out the time lapse. As oil reaches to lower point B, we stop the stopwatch and noted the time. Point 12. We will repeat the same process twice to get accurate readings. Point 13. Now we have to determine the density of the test fluid. For this purpose, we use energy specific gravity bottles. First, we will weigh it with the help of weighing balance. Point 14. Now we add distilled water to the same gravity bottles. Again weigh it. After removing water from it, we will dry it in oven. After drying, test liquid is added again. Weigh it in weighing balance. Determination of viscosity of liquid by Ostwald Viscometer. Calculations. Determination of density of liquid. Observation. Weighing of empty specific gravity bottles, W1 is equal to 20.53 grams, and weight of specific gravity bottles, W2 is equal to 55.59 gram. It also includes the weight of distilled water. And sample liquid, turpentine liquid, W3 is equal to 50.39 gram, and density of the liquid yani turpentine oil, ρ2 is equal to mass of liquid divided by mass of equilibrium volume of water in equal volume of water. So now our formula is ρ2 is equal to W3 minus W1 divided by W2 minus W1. So ρ2 is equal to 50.939 minus 20.53 divided by 55.59 minus 20.53. तो हमारे पास डेंसिटी आ जाती है 0.852 ग्राम पर मिलीलीटर. डेंसिटी ऑफ टर्पेंटाइन ऑयल, ρ2 is equal to 0.852 gram per milliliter. Density of water at room temperature, ρ1 is equal to 0.997 gram per milliliter, standard value. Viscosity determination. Viscosity of liquid, ρ2 is equal to ρ2 multiplied by T2 divided by ρ1 multiplied by T1 multiplied by eta1. ρ1 is density of water gram per milliliter, ρ2 is density of test sample minus turpentine oil gram per liter. Eta1 is equal to viscosity of water Cp. Eta2 is equal to viscosity of test sample minus turpentine oil. T1 is mean time of flow of water from A to B, and T2 is the mean time of flow of test sample turpentine oil from A to B. Viscosity of water at room temperature, eta1 is equal to 0.997 Cp. Density of turpentine oil, ρ2 is equal to 0.852 gram per milliliter, calculated value. And density of liquid at room temperature, ρ1 is equal to 0.997 gram per milliliter, standard value. Now we draw a table to explain this. Liquid sample, time of flow in seconds, mean time seconds, and density in gram per milliliter, and viscosity in centipoise. These are their units. So first of all, we divide our time of flow in seconds into three parts: in distilled water and and turpentine oil. For we take three readings, 1 2 3 for both. And for mean time, we will calculate the mean time T1 and T2. And for density, we will calculate the density for distilled water and turpentine oil. And at last, viscosity in centipoise, we will take the viscosity of distilled water and turpentine oil relatively. Viscosity of turpentine oil at room temperature is 0.9240 centipedes. So precautions: these viscometer must be properly washed and dried before use. The temperature during the course of experiment must be constant, and the distilled water or liquid may be added in the left limb of the viscometer with the help of pipette. Point 4. The viscometer must be dried before the start of each experiment. Point 5. Quantity of every liquid added in the viscometer should be same. Now we will come towards the diagram, and in this experiment we will draw the following diagram of the viscometer. I have also labeled this diagram carefully so that you may also label it carefully according to your practical. Wider limb of transfer liquid, and here is the rubber tube to suck the liquid. Upper part is the upper mark is point A, then bulb 2, and then lower mark is point B. And here is the capillary tube, which is represented as this, and U-shaped tube, and here is the bulb 1. Bulb 1 is on the wider limb side, and on the rubber tube or suction side, where 2 marks are present, there is bulb 2. Hope so this practical will be informative for you people. Be connected with me for more interesting practicals like this. Thank you. Allah Hafiz.